Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, how are you? Hopefully everything is fine today. Today is our final class for chapter 1. We are going to discuss 1.4 definite integrals. Okay. Definite integrals is when our integration has start and end values. In other words, there is an interval or limit or boundary. So our integration no longer ends with constant c. Okay. And normally we write down the limit at the top and bottom of integration symbol like this. 1, 2, 5. Okay, and after we finish, let's say the function is x. Okay, so after we integrate, we got x squared over 2, and we put a square bracket, and we write down the limit. It means that we have to calculate from x equals to 1 to x equal to 5. Okay, this is definite integral. Okay, so let's see what we want to achieve today. At the end of the lesson, students should be able to use properties of definite integral, evaluate definite integrals, find the area of a region bounded by a curve and x or y axis. And also we could find the area of region bounded by two curves and also region bounded by a line and a curve. And last one, we should able to determine the value of a solid of revolution bounded by a curve and x or y axis, volume bounded by two curves and volume bounded by a line and a curve. All right. Let's go over a few properties of definite integrals, and later on we will do simple examples. But before that, you have to bear in mind that this is actually exactly the same as what you have learned in Form 5. So there's nothing new. So today will be more simple topic. Okay, let us take a look at our properties here. Let me number the properties so it will be easier for me to refer later. All right. Okay, let us take a look at the property number 1. When we integrating a constant, when we integrating a constant, we will simply get that constant here C times the quantity of the upper limit B minus the lower limit A. Okay, where C is any constant. So, for example, the integral of 4 dx from 1 to 5 will be 4 times the quantity 5 minus 1, and it is equals to 16. Okay. This makes sense. If you think of the function y here, this is y equals to 4. This is y-axis and this is x-axis. Okay. If we chop this off, and also here, so what we got here is a rectangle. Yeah, we have rectangle with a constant height of 4. So multiplying by the difference of this limit, 1 to 5 is 4, and here is 4. So we got the area of rectangle. Okay. Okay, properties number 2 says that the integral of sum of function over some interval is equal to the sum of their integrals over the same interval, such as, let me read it for you. Integral from a to b of the summation of f of x and gx with respect to x equals to the integral of fx dx from a to b plus the integral of gx from a to b. Okay, and the same goes to the difference of functions. We just change the symbol here from plus to minus, and also here from plus to minus. Okay. Okay, done with properties number 2. Property number 3, similar to properties number 1, if we are taking the integral of a constant times some function, we can just pull out the constant out of the integral, and we get the constant times the integral of the function. So this is the same as our basic rules of integration. Okay, that is properties number 3. And next is properties number 4. Property number 4 says that if both of the limits of integration are the same number, the integral will equal to 0, no matter what the function is. Okay, why? Because we essentially asking about the area under a single point. This one is A, which would be like finding the area of one infinitely thin rectangle, which is just a line. A line has no area, so this integrals equals 0. Okay. Similarly, if we have two integrals of the same function over adjacent integrals, okay, the first one is from A to B, and the second one is from B to C. Okay, so the sum of these integrals is equal to the integral of the function over the whole interval from A to C. So instead of twice integration, we just do it once. It saves time a lot. Okay, the next one. The next one is if the interval of a function that is being integrated is above the x-axis, its integral will be positive. Here will be positive. If instead it is below the x-axis, it will be negative. Okay, the integral also will have negative value. Okay, because this is negative y values. And this property number 6, is very important while calculating area. Okay, while calculating area later on. So you better be careful if the function crosses the x-axis with some portion above the axis and some portion below the x-axis, the integral will be net area. Let me show you. Okay, like this. Okay, some portion is above the x-axis and some portion is below the x-axis. So if we took integral f of x from A to C, it means that we are calculating the area above minus the area below. It means that the area above, let's say the area above is 12 units square minus 3 units square. So it will total up 9 units square. But if we want to get the total area, it is not 9, but it's 15. Because total area between curve and axis is actually 12 plus 3, 15. Okay, so so you better be careful here. That's why when you want to get the area, you have to determine the total. You have to sketch the graph first. So we must be clear which part is above and which is below the x-axis. Then we calculate it, and we have to calculate it separately because we want to get the total area, okay, not the net area. Okay, we go back to our properties. Okay, properties, the last properties number 7. Properties number 7 is about switching the limit of the integral. If we have some integral of f of x dx over the interval of a to b, then if we want to switch the limit, instead of AB, we use B to A. So what happened to the result? Okay, the result is exactly the same as original, but in negative. Okay, but in negative. This is because we are integrating in the opposite direction. Okay, it is if we switch the limit, so the value is the same but negative value. All right. Okay, so done with the properties. We have 7 properties. Now let's start on example. We start out with something simple. Example 29, page 10 in your note. Okay, given integral of f of x over interval 1 to 3 is 5, and integral of f of x from 3 to 8 is 10. So the question is find integral from 3 to 3. So the solution is exactly the same as properties number 4. Properties number 4 said if we integrate on the same point, whatever the function is, it is equals to 0. That is A, and B, integral of f of x from 3 to 1. So what happened here? The given info is integral of 1 to 3. But the question is, it switched the limit. It asks for 3 to 1. So what we do, the value is the same, but negative. Okay, this is properties number 7. Okay, if you cannot remember, you can go back to your notes and look at properties number 7. And C. And C asks for integral of 1 to 8 of f of x dx. Unfortunately, there is no info given for interval 1 to 8. So what we do is we can combine those info here. 1 to 3 f of x is equals to 5 and 3 to 8 equals to 10. That means the answer for C is 15. And this is properties number 5. Okay, let us go to the next slide. Okay, the next slide, example 30, it also has many questions there, but I only choose C. Okay, C asks for combination of 2f of x and 3gx dx. So what we do is we just decompose this. Okay, we integrate it one by one for f of x and g of x separately. Okay, and luckily the info is already given in the question. The integral of f of x from 2 to 5 is 5. And the integral of g of x from 2 to 5 is 6. All right. Okay, so this is 2fx, so 5, we have to times by 2, and 3 times 6, and total up 28. Okay, so this is a question about properties. And now we will go to how to determine the value of definite integral. Let us take a look at example 31. Okay, example 31 asks us to evaluate integral from 0 to 2. We have to integrate e to the power of 4x minus 2 dx. So what are we supposed to do? Okay, the first thing is we have to integrate our exponent first. Okay, I hope you still remember the integration of exponent is exponent itself, but we have to divide by 4. Okay, 4 is the differentiation of the power. Okay, so this is the integration. And this time, we don't longer put plus c because we are doing definite integral. The question asks the integration from 0 to 2. So what we do is we substitute x equals to 2 first. So e to the power of 4x. We substitute x with 2 minus 2 over 4. And then minus again e to the power of 4x. But this time x will be 0 as the lower limit of the integral, and minus 2. And don't forget over 4. Okay, this is how we do the definite integration. Okay, let's see what happened here. 4 times 2 is 8. 8 minus 2 is 6. So e to the power of 6 over 4. And minus 4 times 0 is 0. 0 minus 2 is negative 2. So e to the power of negative 2 divided by 4. Okay, you can keep e as your final answer. You don't have to give the decimal numbers. Okay, this one is accepted. But we can factorize the 1 over 4 to make our answer more simple. Okay, so the answer is 1 over 4 times e to the power of 6 minus 1 over e to the power of 2. Okay, is it okay with that? Okay, so our next question, example 32, we were asked to evaluate the integral of 2x cubed over square root of 1 plus x to the power of 4 dx over a limit from 0 to 1. Okay, so this one is not as simple as example before. It is in division. It means that we need help from techniques of integration. So this case, we will use u substitution. Okay, so I choose u as 1 plus x to the power of 4. So I differentiate u. So I got du equals to 4x cubed dx. All right. So I substitute u into the integral. Okay. Okay, so what happened here is this one. Okay, so what happened here is 1 plus x to the power of 4 is u with square root. And this one, du equals to 4x cubed dx. But we only have 2x cubed dx. So what we should do is we divide. So we divide du with 2. We divide both left hand side and right hand side by 2. And we cut here 2x cubed dx. Okay, so 2x cubed dx is half of du. Okay, and we arrange again so it looks nice. We pull out the half outside the integral, and what's left is 1 over u to the power of half, which is I prefer to be written as power like this. Okay, so this one looks better, right? Okay, so we integrate. A constant remains as a constant, and u to the power of negative half will be u to the power of half divided by again the power half. All right, and half, we cut out that. What's left is u to the power of half, and we have to evaluate it from 1 to 2. Okay, so I substitute. Okay, so before I go further, here is the problem. I put here 0 and 1, but unfortunately 0 is not u. Our integration here now is using u as a variable, but the question 0 and 1 is actually a value of x. So we cannot use 0 anymore. We cannot use 0 and 1 anymore. What we should do is we have to calculate what happened to u when x equals to 0. So when x equals to 0, u is 1. And when x equals to 1, u equals to 2. So I replace 0 with 1 and I replace 1 with 2. Okay, so remember when we change our, our variable, so do the limit of the interval. All right, so now we finally finish our integration and we have u to the power of half in between 1 and 2. So I substitute 2 into u. I got square root of 2. And don't forget this is definite integration. So we have to minus and substitute again with the lower limit, that is 1. Square root 1. Okay. So square root 1 is 1. You cannot write down this as your final final answer. Okay. You must write down square root 2 minus 1. Square root 2, you can remain as square root 2. It's okay. But in the square root 1, you have to write down as 1. All right. This one is not accepted. Must write down 1. Okay. Okay, so let us take a look at the next example. Next example is ln integral of ln 2x dx in between 1 and e. Okay, this time we have to use by part where u is ln 2x according to our law pact. And the other one, there's nothing here. It means that we will integrate 1 dv. Okay, so integrate 1 dx. Yes. Okay, so 1 dv is v and 1 dx is x. Why is it 1 dx? Okay, because we already took ln 2x. There's nothing left there. So it's actually 1 here. Okay. All right. So when we integrate, we got integrate of dv, we got v, and integration of dx, we have x. And we substitute everything in the formula uv minus v du. So we have here x ln 2x minus half x. And we substitute everything. Okay, we replace x with e ln 2e and minus for the lower limit 1 times ln 2. 2 times 1, 2. Okay, settle for the first terms. And we go to the second term, half. X, we replace x with e minus, we will replace x with 1. So, done with the substitution of the value. Now we try to simplify. So while simplifying, we use properties of logarithm. Okay, e ln 2 plus e ln e. All right, minus ln 2, and here we simplify more. We open the bracket, so we got negative e, negative and negative plus 1. Okay, and last one. So e minus e, 0. So finally, we have ln 2 times e minus 1 plus 1. Okay, so done with that. Okay, all right. So that's why in our class before, I asked you to make sure you have mastered all the skills involving integration. Okay, by now you have to very smooth with all the skills by part, substitution, and everything about integration, because now we are applying those. Okay, so done with the definite integral in general. Now we are going to the next subtopic in this 1.4, that is area of a region bounded by x or y axis. Okay. Okay. When we want to find area under the curve x-axis, we will integrate the function of the curve with respect to x. Okay. So, but given the function must be continuous throughout the interval given. Okay. So area is integral of f of x from a to b. Okay. So graphically, it's like this. Okay, this is our function. Okay, so the shaded area is the area in between curve and axis, and uh, this is what given by the integration. That is the area between curve and axis. Okay, so let I say just now, when the function is below the x-axis, it means that the value of integral will be in negative value. Unfortunately, area is always positive. So, to be safe, we always put modulus when calculating area. Okay, so that we make sure that our answer is always in positive value. Okay, so do if the curve is above the x-axis, but this one, it doesn't, there's no problem here because the integral will give you positive value. But again, to be safe, just put modulus when we calculating area. Okay, so that we are sure, 100% sure, our answer is always positive. Okay, we also can find the area in between the curve and y-axis by using integration. Okay, this one is okay untuk y-axis pula Untuk y-axis, it is also the same. To get area between the curve and y-axis, we will integrate the function in terms of y. Okay, we see the graph graphically. It's like that. Okay, it obviously we have the curve and the y-axis here. So the area shaded here will be given by the product of integration of the function. In this case, from C to D. But if we use y-axis, it means that the integration must be with respect to y. So we must use dy. Okay, and C and also D is also the value of y. This is y equals to C and this is y equals to D, right? So our integration depends a lot on what axis we choose. If we choose y-axis, so we will use in terms of y. Okay. And again, make sure we put modulus here so that our answer is always positive. Okay, let us take a look at example 37. Okay. Okay, example 37 said that find the area of region bounded by f of x, where f of x is x square minus 2x. X exists, and line x equals to 0 and x equals to 3. So the area, to be safe, again we will put modulus. But here we can see clearly, because the graph is given here, it is clearly there are two portions here. The first one is section A below the x-axis and the section B below the above the x-axis. It means that we have to calculate it separately. area A and area B. So area A is in between interval 0 to 2, 0 to 2, and area B is in between interval 2 to 3. Okay, so we integrate it separately. So for area A, we got 4 over 3, and for area B, we also got 4 over 3. This is just in coincidence. Okay, all right, so A plus B is 4 over 3 plus 4 over 3 equals to 5 over 3 units square. Okay. Okay, let's see example 38. Find the area of region bounded by y equals to 1 over x in between interval 2 to 4 and also negative 4 to negative 2 and y-axis, right? And y-axis. So according to the graph here, again, we have two separate portions. Okay, the first one we name it as A, and the second one we name it as B. So again, we will integrate it separately. Okay, so to be safe, always put modulus when we try to get an area. But A is in the positive side, so it doesn't matter. We will get positive. Okay, but B, you will get negative value because it is on the left side of y-axis. Okay, so that's why I tell you, when every time we calculate area, just put modulus to be safe. All right, and again, we got the same value here, 0.693 and plus 0.693 equals to 1.386 unit square. This one is the same because these are symmetrical graph. Okay, so for those who are very good in graph sketching, you can always you can just integrate A and then times 2, but you have to be very sure about the graph. If you are not sure, it is safe to calculate it separately. All right, next question. Okay, again. All right, we have finished example about area between curve and axis. Now area between two curve. Okay, is the same. We will integrate the function, but this time because it is between the two curve, so what we do is we have to minus the bigger area, we minus the smaller area. So for this graph, we will take function f minus function g. Okay, and again, to be safe, put modulus. Okay, let us take a look at example 41. Okay, so example 41 also already have the graph. So we are so lucky here. Already have the graph, so you don't have to sketch the graph. If there is no graph, the first thing you should do is to sketch graph. After we have the graph, so we have the rough idea about the location of the area involved in this integral. Okay, so let's see the given area. This time we have two functions here. The first one is the curve y equals to x squared plus 3, and the second one is the line 3y minus equals to negative 2x plus 14. If the graph isn't here, did not provided, so we have to sketch. If we have to sketch, we have to find out the intersection here, okay, by using simultaneous equation. Okay, but this one, everything is already here. The intersection is at x equals to 1, and the x-intercept here is 7, and y-intercept here is 4. So our job is quite easy. All right. Okay. Let us focus on integration. Okay. So we want to calculate curve, area bounded by curve, line, and x-axis. Okay. So this case, it is actually two separate area. The first one is is actually between curve and x-axis, and the area B is between line and axis. So it is not really area between curve. Okay, so as we do before, integrate for a x squared plus 3. So we got x cubed over 3 plus 3x, and we substitute x equals to 1. We substitute x equals to 1. We have 1 over 3 plus 3. And we have to minus x equals to 0. 0 plus 3 times 0 is also 0. Okay, so this time our job is easy. 1 plus 3 minus 0. So total up is 10 over 3. And also for B, it goes the same. We substitute 7 and also 1. We have to substitute it one by one. Okay, so we cut here 12. So total area is 1 plus B, A plus B, 10 over 3 plus 12. Total up 46 over 3 unit square. Okay, you have to try this one. Make sure you know how to substitute it. Okay. Okay. Our next title is to find volume. Okay, so this is uh, our last objective for today, to find the volume of a solid of revolution about x-axis. Okay, so if we have line here, a straight line, a horizontal line here, if we revolve the line about x-axis, okay, if you cannot imagine, you can search in YouTube. There are so many animation that show what happened when the line revolve about x-axis. Okay, what happened here? It becomes a cylinder. Okay, so if you cannot imagine that, please go to YouTube and search for animation of revolution about x-axis. Okay. Okay, let's see here. The second graph here, we have a straight line with a certain gradient. Okay, if the line like this, and we try to revolve the line about this time y-axis. All right, so just imagine we rotate the line about y-axis. Okay, it will become a cone. Yeah, it will become a cone. And the last diagram, if we have half circle, and again we rotate it about x-axis, what we get is a sphere, a solid sphere. Okay, so this is what we're going to find in our last title in chapter 1. Okay, so let us take a look at the definition. Volume of a solid of revolution. It means that it revolves about whether x-axis or y-axis. For this diagram, it shows about x-axis. So the volume of the solid generated by revolving the region about x-axis between the graph of a continuous function f and the x-axis here, from x equals to a and x equals to b, okay, is the integral of pi times y squared dx. It means that with respect to x, it means that we are using variable x. So the interval is also in x value. A is x equals to A, and this upper limit is x equals to B. So what is y? Y is a function in terms of x. Okay, so we write back. Volume is the integral of pi times f of x square dx from A to B. Okay, so what if the question asks for y-axis? Okay, so volume of a solid of revolution when it revolves about y-axis, the volume will be the integral of pi times x squared dy, and x means the x in terms of y, like this. It means that function in terms of y. Okay. And we square up all these function and we integrate with respect to y. We are using variable y. Okay, and interval also in y. This is y equals to A and y equals to B. Okay, so in this part, volume, it is very important to use the correct axis because the different axis will give different solid. Okay, it is not like area. Area, the shape is remain the same whether you use x-axis or you use y-axis. Okay, so in volume is different. You have to read the question carefully. Whether the question wants you to revolve the about y-axis or x-axis. Okay, so let us take a look at the example. Example 42. Find the volume of solid form when the area bounded by the curve y equals 1 over x. Y-axis, y equals to 2 and y equals to 5. And the curve is rotated about y-axis. So write down the formula. Volume is pi integral of 1 over y dy. Why is it like this? Because v is pi and x squared dy, because we are using y-axis, so x squared dy. What is x? The given function is y equals 1 over x, and this does not fit the formula. We have to modify it, make x as a subject, so x equals to 1 over y. Again, then substitute it into the formula. We got 1 over y squared dy. What is 1 over y? It is 1 to the power of negative 1 square. So it becomes y equals to, it becomes y to the power of negative 2. So what we integrate is not 1 over y, but y to the power of negative 2. All right, so we integrate it. We have y to the power of negative 1 over negative 1, and we will substitute 5. Okay, so this is 1 over y, and we have negative here, 2, 5. So the first one will be 1 over 5 with negative and minus, and don't forget to put bracket. And the second one is negative again, but y is now is 2. All right, here. Okay, then calculate it, and we got 3 over 10 pi unit cube. Okay, make sure you do it again on your own. All right, next example. Next example is example 43. So R is the region bounded by x-axis and the curve y equals to negative x squared plus 1. Calculate the volume of the solid form when it is rotated about x-axis. So the solution is, again, we write down the formula, y squared dx. This time we use dx because the question asks for x-axis. Okay. And the interval is from -1 to 1. Okay, write down the function -x squared plus 1, but don't forget to square up. And this is volume, you have to square. Okay, when you square, you have to expand it first. So we have 1 plus x to the power of 4 minus 2x squared. And again, we substitute the limit here. Begin with 1, x equals to 1. So substitute 1 by 1, 1 plus 1 over 5 minus 2 over 3. And then minus, and don't forget to put a bracket. And this time is -1. You have to be very careful because negative value always prone to carelessness. Okay, so x -1 and -1 over 5 and -1 cube is -1 and times negative here. So we got positive 2 over 3. And we finally have our answer 16 over 15 pi unit cube. And again, please do it on your own again after this class. All right, and also between two curves, it is the same as area just now. We need to make sure which region is larger, and we minus with the smaller one. Yeah, and still we have to square, and we also have to be alert with the axis used in the rotation. Okay. So this one, when we use x-axis, so we use dy, and also the interval involved is also the value of y. Okay, let us take a look at example 46. Example 46, find the volume of the solid generated when the area bounded by y equals to sine x and y equals to 1 over sine x for x in between 0 and pi. Is rotated 360 degrees about the x-axis. Okay, so here we already have everything here. We don't have to use the simultaneous equation. Simultaneous equation if the question didn't provide us the graph. Luckily, we have here already stated here the intersection of the two curves is, the first one is pi over 6 and the second one is 5 pi over 6. Okay, so we save the time for simultaneous equation. So directly we use the formula. We use the larger area, that is sine square x, and minus the smaller one, that is 1 minus sine x, and don't forget everything squared. Okay, so this one we have to expand. All right. Expand, we have -1 plus 2 sine x negative sine square x. You have to expand first this one. It is actually 1 minus 2 sine x plus sine square x, like this. And then we have negative outside the bracket. That's why we have -1, negative and negative plus 2 sine x, and negative and positive, we have negative sine square x dx. Please be careful here. Do not careless. Okay, after we have finished expanding, make sure we simplify the function. Okay, luckily we can roll out this sine square. What's left is only 2 sine x minus 1. So this one is a very simple integration. So sine, we have cos. But remember, this is an integration. When we integrate sine, we have negative cos. So don't forget that negative sign. So negative 2 cos x, and integrate 1, we have x. Okay, then we substitute our limit. Starting with our upper limit, we substitute x with 5 over 6 pi, both term, and then minus always put a bracket and substitute the lower limit, that is 5 pi over 6. So we have negative 2 cos pi over 6 minus pi over 6. Okay, all right, so this one you can use calculator. Negative 2 times cos 5 pi over 6 is square root 3, and negative 5 pi over 6, there's remains same, and this one is negative, negative and negative become positive, and this is square root 3, and again this one negative and negative becomes plus pi over 6. Okay, so simplify. Square root 3 plus square root 3 is 2 square root 3, and negative 5 pi over 6 plus pi over 6 is negative 2/3 of pi. Okay, so you can stop here, or you can make it nicer by factorize 2. Okay, pull out 2. 2 pi times square root 3 minus pi over 3. And to make it looks nicer, put unit Q. Okay, but if you didn't write this one, it doesn't matter. Okay. Okay, last one, example 47. It is about region R here, bounded by the curve x equals to square root y plus 3, and x equals to 3. X equals to 3 here, and y equals to 4. Okay, we want to find the volume when the solid is rotated, when the curve is rotated through 2 pi about y-axis. Okay, so we are using y-axis. So the formula is x squared dy, because this is y-axis, and make sure the interval also is in y. Do not mix up with x. We are using dy. It means that we will use the value of y. So y equals the region here, starting from y equals to 0 until y equals to 4. Okay, and then plug in the area. So which one is bigger? All right. Which one is further from y-axis? X equals to 3, or x equals to square root y plus 3. So obviously this one is further. So we will use x equals to square root y plus 3 minus the second one, x equals to 3. Okay, all right, so we substitute it, and then we integrate. There's nothing to simplify, so we directly integrate. We have y squared over 2 plus 4 times y to the power of 3 over 2 from the interval 0 to 4. Okay, and we get 40 pi. Okay, all right, so I think that's all from us for chapter 1. Okay, so I really hope that you do lots of practice, because integration has a very close relation with differentiation, and it involves a combination of differentiation and integration. If you didn't really master the technique, you will get confused with the process of differentiation and integration, because both of them are inverse to each other. Okay, so to be safe, make sure you have enough practice. If you have enough practice, everything will be fine. Okay, with that, that's all for today. Bye bye.